Mark Susich from Emerson to introduce himself and let us know a little bit more about what you guys are doing.
Certainly. Good morning, everybody, and thanks for showing up to the last session on the last day. Really appreciate the audience. Mark Susich, I'm the oil and gas technical consultant with Emerson. 30 plus years in the oil and gas industry, primarily upstream, where I've had the pleasure to implement and manage asset integrity programs on a global basis. Critical to this theme, 10 plus years, defining and implementing remote autonomous inspection, and then working on machine learning for certain NDT methods. Pleasure to be here. Look forward to your questions.
So I guess I'll, as usual, I'll throw it out to the audience. We have a microphone, so raise your hand, and then if you could, just introduce yourself and where you're from, and then ask a question. Here we go. Should be on. Is it on? Yep.
Mike Richards, Johnson & Johnson. Question for Carrie and others. I didn't know whether or not you had said that some of your drone operations, if any at all, were autonomous. It seemed like it would be a good opportunity to have a pilotless open air. Are you doing that now, or if not, looking to adopt that in the future?
Florida Power and Light and Next Air Energy is utilizing autonomous drones like the Perceptos and the Teros that we have now. Vegetation management specific, we are visual line of sight. We're hoping to get beyond visual line of sight under our Next Air Energy, it's called FPL Air group, the first quarter of next year. So right now we utilize everyone else's collection that throughout our company that they're using, but from vegetation, it's usually a plane, a helicopter, even a car, right on the ground. And we have pilots as well that use drones. Right.
Feel free, Drew or Mark, feel free to interject if you have any perspectives.
So for aerial production services, we don't currently do any autonomous flights. We are diving into the space of beyond visual line of sight. We do beyond visual line of sight flying in North Dakota on a specific sector or a specific right-of-way that we have FAA approval to fly those flights on. What's interesting is applying for those waivers and getting the FAA on board with doing those really crosses, they intersect with building a digital twin of the right-of-way. To get approval through the FAA, you've got to know and mitigate every single possible risk that could come up, whether it's a road crossing, whether it's a private residence, and maybe that private residence walks out. How do you mitigate that risk? So building a digital world to be able to show the FAA, these are the steps that I'm taking to mitigate those risks, really accelerates and improves your chances of getting a BVLOS approval. And as Tim said, there's thousands and thousands of BVLOS approvals that have gone out. There's very few companies that are actually executing beyond visual line of sight flights. And where that fits in with automation is once you can get that BVLOS step done, flying beyond visual line of sight, then you can start working in automated flights based upon what you've learned from BVLOS. But we've all got to take that step first. We've all got to understand the risk and mitigate all those risks before we can take that next step to automate these flights and do it safely.
Yeah, I'll just add on that, Emerson, they cut their teeth, their genesis was in the mining industry. So you could imagine if this was a cave, 1,000 meters below grade, there's no GPS. So, their capability is autonomous flight. It'll figure out where it is. You can give it a waypoint and get from point A to point B. In the oil and gas sector, as Bank of America, I think, pointed out on Tuesday, oil and gas, we're very undercapitalized in that digital transformation. So it's a target-rich environment. Where you're seeing growth is in the offshore industry. So flying a UAV, capturing data in the undersides of a platform. I can't see it, but I can program that drone to go down and collect data. It's safer, faster, and cheaper than rope access, building scaffolding, or hanging someone over the side. We're just in the infancy stage of adoption. And there was another speaker yesterday. You don't know you have a problem until someone shows you have a problem, and here's a solution to address that problem. So we're low in adoption of oil and gas, but it is a target-rich environment.
Anybody else?
Dave Dollar with Hexagon. How are you dealing with hazardous gas environments, classification, class 1, div 1, class 1, div 2, specifically for the drones?
With the equipment that we're utilizing, especially on the drone, we can stay outside of those classification spaces. We don't have to get that close to them. These laser scanners have a pretty wide field of view, and as long as you can get an angle in to capture underneath the pipe from 15 feet away, then the data is going to be just as good as if you were right beside it. And then flying, we don't have to get right down on the pieces of equipment. These LiDAR systems are quite robust to be able to capture good data from 10 meters high or 15 meters high, and even further than that. I think the Innocent hover maps range is up to 50 meters high or something similar to that. Of course, there's other LiDAR systems that's the typical range where you would fly it at. The versatility with the hover map system for that compressor station is we could fly it lower, still outside of those classification spaces, but we could get different angles that we wouldn't be able to get with other LiDAR systems.
That's a great question. That's really the crux in the oil and gas industry. Any sort of hot work, electrical charge, discharge, powerization that could create that infamous blue spark ignition, that's a no-no. So all work is permitted under a hot work permit. So the atmosphere is assessed. It is ensured that any sort of hot work that could create that spark, it is managed under a work permit. So if this was a module, either onshore, offshore with process equipment, think of vertical, horizontal separators, a bunch of pipe, walkways coming in, going out. I have fugitive gas, it's leaking off a tubing, valve stems. It's there, but in low concentration. So the robotics, whether it's spot, whether it's a crawler, whether it's a drone, to do work in there today, most likely is in a hot work permit to manage the risk. The payload, the sensor package, that too, if it has the potential to create a spark to be ATEX or Div 1 Class 1 certified, is probably going to be a lot larger, a lot heavier, and enclosed. So we have to work with the delivery mechanism and the payload eventually to be both there in a hazardous environment. Okay, great question.
Anybody else want to take a shot at that one or no? Okay.
So I have the mic.
Question, go ahead.
So first of all, thank you both for those presentations. Outstanding work. I think that's amazing to see those kind of direct examples. My follow-up question is for Carrie. And so when you're flying drones in like the neighborhoods and things like this, how high do you go? And I would imagine at some point residents freak out because there's extra activity. How do you have to communicate that to people?
We notify the customers prior to drones being in the area. Oh, sorry. Can you hear me? We notify the customers prior to the drones being in the area. I'm with the vegetation management department, but we have many other departments. So there's automated calls going out. There's mailers going out. There's a phone number if they have any questions prior to the flights happening that they're able to call, and we're able to work through. Did you ask me how high also we're flying? For vegetation management, specifically for LiDAR, we're about 250 feet above the lines.
Is 400, my understanding, is that the kind of, for the FAA, is that the normal altitude for BVOS? I think it's around 400, yeah.
400 feet's the ceiling for drones.
That's kind of the FAA ceiling for pretty much most flights. 400, yeah. That's kind of that's for, if you want to go BVOS, that's my understanding is 400 that's it.
So great presentation. I see some of that stuff and think, okay, I'm living in the future. And at the point you're living in the future. So my question is, from your perspective, well, you're already living in my future, what's your future? What are you thinking that's going to be coming along in 3 to 5 years that's blowing your mind? And we've talked a little bit about the autonomous flight. Are there any other things that you're seeing that you're expecting, I'm going to be here in 3 years' time, and you're going to be presenting another one, which is going to be equally amazing.
For my space and vegetation, it's more what I talked about, predictive growth modeling, understanding the change detection from one flight to the next. That's really big for us. So I don't think it's quite 3 years off, maybe half that time before we really have a solid handle on that. And really just equipping our inventory, our partners, our vendors, having them also integrate some of this technology into their workflows and processes as well, right? When they're done, maybe on their trucks, on their person, right? Collecting imagery that way as well.
I'd like to add to that, if I can. So this will make you laugh, a little humor last day. So here's the journey I've been on. My first inspection data management software program was DOS-based. My first cell phone was a Motorola Brick. My first PC was an IBM 386 with a Mathco processor. My cell phone today has more computing power than the Apollo missions. Today a technician in the field, we have wearables, HoloLens, RealWear. If they have a problem in the field, they can speak to a center of excellence anywhere in the globe as long as they have cell phone. So if you need real-time support, I could have that 24/7 with COEs strategically displaced or placed to support your operations. You see the onset of machine learning, data visualization, AI. I'm a big sci-fi person, so Terminator, 2001 Space Odyssey, it's coming. What excites me, I wish I knew what I know now. I wish I could wake up Monday morning at 25, because some of you younger people in the audience, it is going to be a very exciting future of the next 15 years. The pace, what has happened in the last 30 in my career and what's going to happen in the next 5, 10, 15, it's hard to define. So the tools are getting smarter. You're able to leverage the data. I think the biggest challenge for any operator, regardless of sector, what data do you need to make sure that your operations are safe, reliable, and effective? And whatever programs, whether it's reliability, mechanical integrity, do you have the right tools? That pushes the burden on your service providers. And I love the challenge I heard yesterday in the opening mark on the software people, so that they really need to get their act together. There's more collaboration, more open source. So if you want to switch from a Bentley product to GE Digital, that's a seamless process rather than tens of millions of dollars. In my industry, we're undercapitalized, but it's a bright future. As we transition to a more green, we'll call it business model, we need technology. And I don't know what the next 5 or 10 years, but I know there's very smart people working on solutions. And if I was a young person joining the oil and gas, I'd be rather excited, because the power of sitting a 3D model in your office in Houston and looking at a plant in the desert of Oman and talking to a technician maybe in Aberdeen offshore in the North Sea with a similar problem, didn't have that 10 years ago. So the advancement is going to be huge. Whereas, hover map and technologies like that, you're a fast, a leader, leading edge, fast followers, and then adoption. So exciting times.
From my perspective in dealing with the oil and gas industry and where do drones go? Where do they have a place? Where does all this data lead us? It's interesting because the data that I'm collecting now for a specific problem today, I'm going to utilize 5 years from now. I'm building off of what we're learning today. We're capturing sites, we're digitizing them today. We're doing that now. How does that help me 5 years from now? I'm going to build autonomous regional inspection services from that. So beyond visual line of sight, it's going to come. It's hard to get, but there's got to be people out there like our company that is pushing hard on the FAA to allow us to do these things, to push the limits of BVLOS, to be able to understand what we can do. So past BVLOS, that's where the regional operations come from. One pilot inspecting 150 well pads out in North Dakota, all autonomously. he's monitoring one station with multiple drones flying, collecting methane data on each of those well pads, feeding that directly to our customers so that they can make the decision to which leak are they going to fix, reducing greenhouse gas emissions across the board. But we have to start where we are now, and we have to not only solve the problems for today, we've got to look forward. We've got to utilize the data that we have to be able to build what we're going to do in 5 years.
Okay, my name is Becky Morgan. I work with manufacturing companies, and so this may well be a selfish question. I apologize, indulge me. Drew, you talked about doing the inside of the compressor building. Can either of you, and I don't really expect you to be able to answer this question, can either of you speak to real life examples of how manufacturing companies are using drones inside their buildings to help understand equipment conditions or anything else?
So along with the point cloud data that you gather from the interior of the compressor station, laying out exactly where the piping is coming in and going out, understanding how big your compressors are. What if we've got to replace a compressor? How are we going to get it in? What's the dimensions of the building? And then, of course, layering on visual aspects of it. Maybe it's I don't know if you've seen the 3D inside a house, viewing things that you can go in, doing the same things in there so that you've got a visual. You can colorize those point clouds. You can model it. You can see corrosion issues. You can see where your valves are at. You can see all of the information in one place and one visual place on whatever software is out there. You take your pick, but they all have those capabilities to tag certain information that's key to you and is important to your company, and tailor make all of those, the interior of the compressor station or manufacturing site just for you. So
I'll build on that. The capability of remote and autonomous inspection is still in the infancy stage. So SPOT, the robotic solution, 700 of them deployed worldwide. In my industry, oil and gas, most are still walking around using a camera to look at an analog gauge. So way underutilized in Mark's opinion. So the dawn of the era of sensor fusion. So what kind of sensors do we need in the plant so we can collect that data and take the human out of it? And that's really in the oil and gas, we're trying to do reduce risk, reduce that head count, especially in an offshore environment, because most people in this audience don't realize your critical path or your constraint is a bed. Without a bed, I don't do work. And if all the beds are full, I can't get work done. So the robotic solutions out there, whether they're crawlers, whether they're spots, whether it's a drone, the future is bright in the sensor payload, making sure we're collecting the right data and then having the analytics on there for the insights. Again, going back into your manufacturing plant, is it safe? Is it reliable? Do I have the uptime? Are you hitting your metrics? And so we're, from an RAI perspective, there's a lot of runway left. I think we're just beginning, because the sensor fusion and data fusion, we're not there yet. We're just not there yet.
Hello, my name is Fabio. My question is for Gary. I was wondering if you can describe a little bit the workflow from the moment that the drone flight is done and the LiDAR information is captured. If you can comment what happens to that drone, who takes the information off the drone, where does that get loaded to, who adds the GPS coordinates, and then finally, if FPL itself does the model training, or if you use a third-party vendor to do that for you.
Sure. We have different collection methods, but essentially the pilot will collect the data and produce a raw LAS file, which then we feed into visual intelligence, who will then classify the point clouds, design the work, if you will, understand the encroachment. That is then fed into our work management system and then sent out to the crew for execution. So essentially the pilots will collect the data and upload the data to an Amazon S3 repository. We do have a person at that point reviewing the specs of the data to make sure that it meets certain specifications, that it can be used in a proper way. There's data that can be used in this way to go into visual intelligence. It's inside the platform itself, right?
Hi, I'm Andrew Dark. I work in fishing, so listening a bit on the offshore side. One of the challenges we face is extending the reach of the boats in terms of the sonars and listening to what Tim mentioned about the 30 minutes. What's your views from the three of you in terms of what's the current flight times you can achieve, and what's your views in terms of how far do you think it could potentially go? Because for us, we need a maximum reach. We need much more time, flight time, to be able to get a much greater scope of what we're seeing.
And this is from a drone perspective. What kind of flight times are you trying to get to?
Yes, the further you can go out, the existing sonars can maybe reach out, I don't know, about 1 kilometer. What you want is that with drones, you can go much further out, 5 kilometers, 10 kilometers, and that means time. And you also want to cover a much greater area. And you don't want the drone to run out of battery and then fall in the sea.
So I think we're all kind of in the same position with battery life when it comes to drones. And even in the car industries, you look at Tesla, everybody's rushing to get who can get the most range out of the piece of equipment that they're using. For your situation, especially if it's offshore and not within like the FAA's control, then you're talking more of maybe a hybrid type drone where you're not using all battery. Maybe you're using hydrogen and running generators to run the props. And those types of solutions, you can get 2.5, 3 hours. And I've seen some of them that are saying they can get 5 hours of flight time. I haven't tested any of those, but that would be, if I'm looking to solve that problem, I would look into the hybrid drones situation. So.
Yeah, I'm not a drone expert, but there are commercial solutions out there that have tremendous payloads. They're like a miniature version of a helicopter, so they're out there today. The inventory is growing and their capability is growing.
Yeah, you can do, some of the tethered ones I've heard they can go up for 10 hours. It's just a question of the range. And then if you talk about the hybrid, some will gas and battery operated. So there's some of the ones that are fixed wing. They can, they're pretty expensive, but they can go, they can do, long distances, multiple hours, tens of, 50 mile, 100 miles maybe, or something like that. But most of the ones, the rotor ones, you're going to get plus or minus. I think DJI just came out with a new model, and they were saying maybe, 50 minutes. And I was asking someone, well, how much payload is that? And I don't think it had a lot of payload, because obviously, as you add more payload, obviously your battery power is going to be reduced. So it's always battery technology, like anything. It's smartphones, anything. It's cars, electric vehicles. It's a limiting factor. So I think there are options out there, but it's also a trade-off of how much money you have, and because some of these guys, I saw a video. Shell was using one of these in situ drones, and they had a guy at the remote control center. I was talking about the remote controls, and then there's a company that's Hala Sky, HHLA Sky. Their parent company is HHLA in Hamburg, and they do all the port operations and things like that. And they had a unique situation for their operations. They basically had to build their own drone solution. And these guys are ex-Siemens guys, so we were talking. I said, knowing you guys are ex-Siemens, I said, you over-engineer the hell out of it. But they have the most, in my mind, the most comprehensive end-to-end solution of drones I've seen. They can manage over 100 drones remotely with one guy in a remote control center. And it's pretty fast. And they're coming up. They told me they're coming up with a drone-in-the-box solution. So they've been focused primarily in that, because that's their big spirit. 180 customers, but they're mostly port and container guys. But they're looking at, could be applied to wind turbines, oil and gas. I would recommend checking out that solution, because they pretty much built a nice drone solution. So it's a bigger size, because I think they have ranges of like 3 kilograms, 10 kilograms. So there's different payloads they can carry, and it's a pretty impressive end-to-end solution. Okay. We have another question. I'm sorry.
Hi, I'm Mike Davis. I'm with Novatech Automation. For the whole panel, but Carrie got me thinking about that. You said FPL has other uses besides vegetation management for the data you collect. And I was wondering if you have reached out or been contacted by anyone that wants secondary or tertiary use of this data, because your LiDAR data is unique. I don't know if there's someone at UF in Gainesville that is interested in how vegetation is changing over time, or invasive species of plants, or it can go on to anyone who wanted a 3D model of some part of Florida. You've got it already. I was wondering if any of you have thought of commercializing your data or
Opened
been
up a whole,
approached in
yeah,
that way.
it's a whole new thing. It's just, in my mind, I'm thinking it could be a whole different business model. You'd be selling, you'd be selling data in the future, not just,
Right. I don't want to say no. I'm not privy to that, but I know that we understand that we have data that can be used far beyond what we're using it for. So those conversations will be had in the future.
Yeah, you've touched on a really good point. The technology, Emerson's technology, its speed of data acquisition compared to traditional tripod terrestrial systems. So think of emergency response, flooding of an area, a bridge collapsing, an explosion, an industrial accident. So you could, if you had the before, you could quickly acquire the after. So from condition monitoring, emergency response, there are, I won't say endless opportunities, but we're just beginning to tease those out. Really, there's a lot of educating the operators, the plant. Here's how we can help you. They may not know they have a problem. We may have a solution that could solve many problems from a data ingestion and decision-making process.
And to touch on that, oh, sorry. Just to touch on that a little more, we're experiencing the same, inhibitors that we talked about, battery life, right? Visual line of sight only, the payload, trying to jump, the sheer number of miles. But thinking of it in the terms of where you are and letting our pilots know this data is used beyond just what you're looking at right here, right? So keep that in mind, and you have to factor that into the equation as well when you were looking at the time.
And there are other entities. Take Texas, for example. They go out and do LiDAR scanning of their entire state. I think that some division within the state of Texas goes out and captures all of this. But you also got to understand what's your use case. I mean, if you're utilizing that Texas data, we can show you some comparisons. They're flying it from a much higher height. They're getting, maybe a point per foot is the density of their point cloud. Whereas if you're flying it with a drone, you could get upwards of over 50 points inside that foot. So if you're looking for 1 foot contours, maybe that data is right. Maybe you can utilize it for another purpose that you're looking for, but you got to understand not all point clouds are the same. They're used for a lot of different things, and I believe Carrie's Florida Power and Lights, they utilize a multitude of different LiDAR sensors to capture, maybe it's vegetation, maybe they need it on a drone, or maybe it's for transmission, and they can utilize a helicopter with less dense point clouds to get the data that they're needing. So,
any more questions? Well, we got about a few minutes left, and if there's no more questions from the audience, I'll just ask each of the panelists up here to sort of just give a minute or two, well, probably a minute, I guess, with the time. Just sort of any last minute thoughts or key takeaways that you want the folks in the audience to kind of, really take home. Could be just a synopsis or whatever.
My key takeaway is that you have to try. You have to get into this space to see, right? You're never going to know unless you do that. And some of the initiatives and the innovation that we're doing, it's really exciting to see, the Percepto, Spot, all of that you showed, we're incorporating, and we didn't know necessarily all the use cases we would have for these equipment, but we put one in our mind. So the takeaway is jump in there and see, right? You're not going to know unless you take that first step. And I encourage everyone to do that and be innovative, right? Be disruptive. And that's how we're going to change the industry.
Amen.
I agree. From a service provider standpoint, we're always trying to find new business and things like that, but that's not our major push. We're not going to continue to grow as a company unless we educate, the rest of the the people out there that are looking to do this. So we'll partner with people. We'll help guide them. Okay, so you're jumping into this brand new. Let us help you dodge some of the hurdles that we've already hit up against and spent countless hours trying to figure out a way around. And that's how we push this industry forward. It's not charging you for, a phone call to say, hey, how did you accomplish this? How did you get around this barrier? But communicating across the industry and saying, this is how you get this done. And if you ever need any help, give us a call. And we're always here to push this forward because it's in the best interest of our company too.
I get to close. As an ex-operator, work with a cross-functional team. Don't try to solve a problem in a silo. Bring in maintenance, reliability, HSE, whatever the construct of your organization. Have representation from multiple disciplines. 2, be bold. You don't know what you don't know. And there are others out there that may be working on a solution you're just not aware of. So you've got to have access to a pipeline of information or technology, whether that's through forums or workshops or strategic partnerships. In my career, I was always able to deliver a solution to solve a problem when I worked with a strategic partner rather than to design it in-house. I always had a better product, faster, cheaper, minimal viable product. I could go out there, I could test it, influence it rather than self-development. So I would just encourage you, keep an open mind. If you're in the oil and gas sector, at times we're cavemen. We're behind the manufacturing curve. The data here supports that. A bright future, remote and autonomous inspection. It's a game changer. We're going to repurpose our workforce. It'll be safer, more reliable because hydrocarbons, we need them. My unborn grandchildren will have hydrocarbons in their future. They may be less, but they'll still be there. So be bold.